Right. So now we are reaching a very critical stage of this topic and of the course itself. We are now converting our words into embeddings. We've been talking about this. We first started with the just normal text, and we learned how the normal text is tokenized. So this is the tokenization stage. We're using a very simple tokenization scheme. Where, as an example, in this diagram, where we are just splitting by the white space into separate words, and then we take their IDs. But here we can use byte pair, as we saw that we can use byte pair, which performs better and which was used for GPT-2 and GPT-3 and all of those GPT models. Then we, for each one of the tokenized text, we get their IDs from a vocabulary. From a vocabulary. The one that is that was used for GPT, if I remember well, I think it had close to 50,000 or 50,000 and 50,000 and something words. I think it was like 50,257 token IDs. And makes sense. Maybe this. That's why the token ID for this is 40,000. So now we change it into token IDs. Then we are at this stage now where we are creating the input token embeddings. That's what we want to create now, input token embeddings. Because once we can create those input token embeddings, these models, they are neural networks, right? They are deep neural networks. They want to do, they can be trained using something called backpropagation, and you can read up on backpropagation, but essentially you calculate gradients. We did differentiation in high school. It's essentially the same thing, and you cannot differentiate on words, or it won't be easy. It'll be difficult or impossible to differentiate on these discrete IDs because they are discrete, like one, two, three. That's why we want to differentiate on continuous vectors like these. So we will do our differentiation on these using those values. So that's what the decoder would do. Get those values, do some calculations. We're going to see the calculations later, but do some calculations and all of that. And then there are going to be some post-processing steps that we are going to talk about later, how to convert back the numbers that come out of that, depending on the task you have there, output text. It could be a class, it could be the next word, whatever it's going to be. So this is what we have. So let's get into how to create these embeddings. We can get into the code just to show you there because writing them down, I don't think it will be useful for us to write everything down right now. So in the code here, imagine we have this input, we have these input IDs. Those are the input IDs. It's going to be ID number 2, ID number 3, ID number 5, ID number 1. And ID number 2 is in position 1. ID number 3 is in position 2. ID number 5 is in position 3. And ID number 4 is in position 4. Those are the ones that we have. And we have these IDs after we have done tokenization. No matter what the words were, these are the IDs that we have now. So to make it simple, let's just look at a vocabulary of 6 words, and then the embedding that we want to do is just 3, the size that we want to output. We want to convert these IDs, these token IDs, each one of them into 3 dimensions. Just like the sketch that we had at the beginning of this video, each token ID was being converted into 3 dimensions. So that is the embedding size. And the vocabulary, let's say we only have 6 words in the vocabulary. So this is going to be vocabulary size, and this is our output dimension. What we can do is we can instantiate an embedding layer using torch, which is vocabulary size as the number of rows and output dimension as the number of columns. So this is our embedding layer. It is a 6 by 6. It is a 6 by 3 weight matrix. These numbers, let's just print it. These numbers here that are there in our embedding weight matrix, they are just instantiated like randomly. Although we put a seed here just for reproducibility, they are actually just instantiated randomly, right? These will be optimized during training. The embedding layer is also optimized. But for explanation right now, let's just imagine this is the actual embedding layer. So how do we convert now these metrics, these token IDs into embeddings using this matrix? Quite simple, quite simple. If we use that embedding layer and we want to get the embedding of this token ID 3, it's simply a lookup into the matrix, is embedding matrix. So we'll then go, okay, we are looking for ID 3. This is 0, ID 0, because Python starts off counting at 0. ID 0, this row is ID 1, this row ID 2, and this row is ID 3. So if our token is a token ID of 3 in our embedding matrix, in our embedding matrix, this one here, from the embedding layer, we just do a lookup. And then we look up with this as the index. So it's going to be index 0, 1, 2, 3. So this is the how we can convert that token ID 3 into embedding. So that we get this as the result. That is the result of converting token ID 3 into those 3 dimensions using our particular embedding layer. So here we emphasizing that we know that it's the fourth row just because of how Python starts counting at 0. So 0, 1, 2, 3. And it will be in the fourth position. So to embed all our IDs, we'll just put embedding layer and we just look up all our IDs. Let's see how that can be done. Let's actually go and sketch this in our sketchpad. Okay, so back in our sketchpad, let's now imagine. So let's look at something. Just getting my notes right here. So imagine that this is our weight matrix for with the weight matrix of the embedding layer. So if this is the weight matrix of the embedding layer, it's going to take a bit of time to actually write this. But imagine this is the weight matrix for the embedding layer: 0.3374 minus 0.1778. I don't need it to be accurate because uh, we say these are just these are going to be optimized during training. It doesn't need to be extremely accurate. It just needs to put the point across, right? Okay. 12753, and then we have then minus 0.1606, and then I'm trying to be careful so that at least I do not mess up the example. 1 2 3 4 then 9666, so I do not mess up the results that I will show you. 8 1, 2 more rows, and we should be close to explaining how this lookup is happening. 6315, and then the last one is minus 2 or 8400, minus 0.7849, and then here minus 1.4096. Perfect. So as imagine our input, right? The input that we had. So this is our weight matrix of the embedding layer, and we want to convert these token IDs. So the token IDs that we want to embed are these 2351. Those are the token IDs we want to embed, right? We want to convert them into their 3 dimensional representations. So what we'll do is we'll look at 2. We'll be like, oh, 2, it's in the first position. The first position is saying go for the look up the row in the weight matrix that is in index 2. Cool. This is index 0 according to Python. 1, 2, 3, 4, 5. So for our position 2, what it is going to get is this index here. So it's going to get this row. So it's going to say 1.2753 minus 0.2010 minus 0.1606. That's it. Then for this one, we say for the second row, or for the second position in our tokenized, in our embedded, look for the third index in the weight matrix. So the third is this one here. So it'll be minus 0.4015 minus 0.966 minus 1.1481. And then for this one, for the third position in our token IDs, because this is the first position, right? First position, second position, third position, and then this is the fourth position. So in our resulting one, we'll also have the first position that got the second index. The second position got the third index. The third position is going to get the fifth index, which is this one here, minus 284007849. I know I said 00, but the extra zero doesn't really matter. And I think it was actually a mistake in there when I was writing it. Cool. Then the fourth position in our resulting embedded token IDs is saying get the one from the number one index. So it's going to be 0.9178 15810 1.310. Cool. This is we have embedded our token IDs. That's pretty much it. That's really what is going on in the background. In the background, it is a lookup table, sort of. But technically speaking, it is doing what is called a bit of matrix multiplication. It does matrix multiplication in the background, but to just make it easier to understand, it is doing a lookup in the embedding table that it will be optimized during training. That's really it. That's really it that I wanted to explain in this part here. Uh, so in the next part, there's a slight change we need to make, or a slight update we need to make, or slight addition. We have done well so far, and it is great that we have explained the embeddings. But the problem is these embeddings, they are not respecting position. As you can see, imagine here we had a token ID of 2. Let me leave that for the next video. You can think about it, so I'll see you in the next video.